Taiwan is under attack. Unpredictable forces of nature threaten the ambitions of this Asian economic giant. To fight back, the island's best minds race to deliver innovative ideas. High-tech factories that manufacture ultra-safe building blocks and assemble them ultra-fast.
我们可建筑时间呢，往往用不到一半。
Now, Taiwan's unconventional construction method faces its ultimate test. How to prefabricate buildings of all shapes and sizes. A billion-dollar high-tech factory, a 22,000-seat stadium, and a towering 38-story residential block. Tempestuous weather, near impossible deadlines, and the constant threat of earthquakes combine to make the engineer's job even tougher.
This is like Lego, but it's a million times harder and bigger.
If they succeed, Taiwan's prefab magic will become a man-made marvel. Taiwan, a mountainous island more than 30,000 square kilometers in size. Home to 23 million people. Rapid industrialization in the late 20th century transformed it into an Asian economic giant. Its foreign reserves are now among the world's largest. But Taiwan's growing economy is vulnerable. The island is continually attacked by one of nature's most destructive forces, earthquakes.
We have about 200 earthquakes of magnitude 5 every year. And then perhaps we have earthquake of magnitude of 6 about every 3 or 4 a year.
Taiwan's geological instability is due to its position on the Earth's crust. It sits precariously on the fault line between the Eurasian and the Philippine Sea plates. Constant movement between these two creates powerful shock waves, producing the many earthquakes experienced by Taiwan, dangerously exposing its densely populated cities to potential devastation.
Many buildings may not be sufficiently strong enough to resist the earthquake force. Beams and columns could be cracked, and even more seriously, building could be collapsed and causing loss of lives.
September 21st, 1999. Taiwan's worst nightmare came true. A massive earthquake, more than 7 on the Richter scale, strikes the small town of Chi-Chi. It's so powerful that it even rocks Taipei. In the end, more than 2,000 people lose their lives. The disaster, named the Chi-Chi earthquake, cost Taiwan around $9 billion in infrastructure damage. Coming up with stronger building methods is now Taiwan's immediate priority. Government agencies and universities begin exploring innovative ideas to strengthen Taiwan's buildings. Multi-million-dollar city icons like Taipei 101 spare no expense to arm themselves with state-of-the-art anti-earthquake devices. Amongst the many individuals working to create unique solutions is engineer Dr. Samuel Yin.
9/21当然这个是非常非常震撼人的，我觉得很悲哀。那如果选一个好的工法、好的材料、好的管理，地震来的话呢， 学校的受伤可以降到最低啊。在压的时候呢，
Dr. Yin is quick to identify the source of a building's vulnerability when facing an earthquake. It's columns and beams. An earthquake attacks them with its powerful lateral movements, violently bending their steel skeletons and causing the concrete bodies to shatter inside and out. As soon as they collapse, the building they hold up is as good as finished.
你看，另外里面这一个，它这个是传统的钴金的，压的时候它整个都弯折掉、变形、爆开来了，这样的话房子就要垮了，它的腿骨都断掉了。
Dr. Yin's solution is to replace the squarish shape of a standard beam or column steel skeleton with a unique circular design. He calls it the Yin spiral. The Yin spiral is twice as stiff to keep its shape during the fiercest quakes. It can also dissipate energy more evenly to keep the concrete around it intact, preventing the building it supports from collapsing.
这圆的东西的维数的强度是方的东西维数强度的2倍，所以用量呢可以省1半。这少用钢呢，就等于节能减碳。
But turning Dr. Yin's unique design into a reality is easier said than done. Construction normally takes place on-site, exposed to erratic weather conditions, and prone to human error. Dr. Yin turns to the magic of prefabrication or prefab construction for a faster and more accurate alternative. Unlike traditional construction, prefab takes place indoors where the climate is controlled, making the work super fast and hyper efficient. The finished building blocks are then assembled rapidly on location. It's like putting together a mega Lego set on steroids.
那过程就是一系列的把它分割开，然后重组起来。
Convinced he's found the perfect method, Dr. Yin builds Taiwan's largest and most advanced prefab plant. 10 soccer fields in size. So efficient, it can churn out 100,000 cubic meters of concrete blocks in a single year.
那任何人盖的话，需要1整年的时间，但是我们只花了108天。
The plant's biggest challenge? To customize their prefab process for buildings of totally different shapes and sizes. A $1 billion high-tech factory, a 22,000-seat stadium, and a towering 38-story luxury residential block. Tough deadlines, the unforgiving Taiwanese terrain, and the threat of typhoons will take engineers to breaking point. Will success seal their reputation as Taiwan's genius builder? Taiwan, home to one of the world's largest prefabrication factories. The giant work floor, 10 soccer fields in area, manufactures concrete blocks for mega buildings, ultra fast and ultra strong. Unlike conventional structures, these prefab buildings can also withstand the most violent earthquakes.
摩洛哥建筑，第一个呢，品质呢比传统的高很多；第二呢，时间呢往往用不到1半，效率很高。
The secret to this factory lies in its finely tuned 4-stage process. the steel shop, where high-grade steel is cut and bent into shape. The assembly line, where the steel skeletons of prefab building blocks are put together. And a concrete casting and molding facility, where the mega building blocks get their final shape, ready for delivery.
详解考进，陈尚汉、王振颂，我们今天很高兴。
Operational efficiency is crucial, but it's the ingenious machines that give production an edge. Giant spring manufacturing equipment churns out unique steel spirals that form the skeleton of columns and beams. It's an eco-friendly process that reduces the demand for raw steel by 30%.
这个地方是我们生产的起点，也就是说我们的钢筋加工生产的区域。那我们是用机械呢来代替人工，对这个产量的提升有很大的帮助。
The factory is geared up for the challenge ahead. Time now to turn theory into practice. Are they up to the task? To prefab 3 massive buildings of different sizes and shapes in record time. The Taipei Stadium, the 38-story Ocean Blue condominium, and the largest of all, the 600,000 square meter Innolux plant. Innolux is a homegrown liquid crystal display manufacturer in Taiwan's rapidly growing IT industry. The billion-dollar business is one of Taiwan's most important exports. For companies like Innolux to stay competitive, they require high-tech factories to assemble their sophisticated products. The faster they get their factory built, the earlier they can generate income.
60层这个状况就是说，因为这个60层事实上这个上面的企业不是我们的企业。
Innolux's latest factory is their most ambitious to date. In 12 months, engineers have to complete the building and also make it earthquake-proof to protect the factory's sophisticated equipment.
但是绝对不可能。
It's a punishing set of challenges that no standard building methods can meet. Except for prefabrication.
Here we have the rebar cage.
Engineer Mo is in charge of constructing a building that's up to the job.
You know, in the conventional way, if we want to build such a big project, we usually take 2.5 years. Now we only take 1 year.
Work starts on the plant's massive foundation. Engineers excavate a gigantic area measuring 100,000 square meters. Thousands of tons of steel piles are welded together to form the building's 6-story framework. But these are the easy parts. The biggest challenge is to tailor-make the floors of the plant's largest cleanroom facility. Cleanrooms are the most important part of the factory. They prevent environmental pollutants like dust or microbes from ruining the microchips that Innolux manufactures. Inside, a filtering system controls air contamination levels through multiple ventilation points built into the floor. This means that cleanroom floors are riddled with large holes. So how do you construct a giant floor filled with hundreds of holes while making it earthquake-proof? The engineer's plan is to split the cleanroom's 48,000 square meters of flooring into 1,800 smaller sections, making them easier to prefabricate. Then, to strengthen each piece, they will double the amount of steel and concrete. At the same time, a massive net of steel will form the frame of the floor, holding the pieces together. In this way, the customized floor is strong and stable enough to withstand the most violent quakes. With the perfect plan in place, the prefab factory now needs to build the perfect floor. First, a crack force of craftsmen binds the steel skeleton of each floor slab together. The work is fast-paced and done entirely by hand.
And then we have using this skeleton put inside of the mold. Here is the mold. Here you can see because that they have all these grooves and then all the skeleton of this our concrete slab. They will be fixed into the right location. After the skeleton inside, and we put the bucket inside here, and then we cast the concrete.
As the concrete is poured into the mold, the plastic buckets help to form the shape of the vital ventilation holes. With just 22 molds, the factory is able to prefab all 1,800 floor pieces in less than 3 months.
And because we have to insert all these tubes to get the ventilation, it looks like a cheese, so that we call cheese slab.
The last stage of the process is to install each of the 25-ton floor slabs. Not on the ground floor, but 4 stories up. For engineers, it's the most dangerous part of the construction.
The most dangerous things is you can see for this 25 tons slab, we have to lift it up to about 30 meter height and insert into the about 10 meter narrow gap.
For a job like this, you need a heavy lifter. A 120-ton crane capable of hoisting these giant blocks into place. A crew at the top slides and drops the massive sections into the steel framework.
You can see, now it's up to the right floor, and we have to get that one into that one. The most dangerous part is inserting the slab. If it doesn't make properly, then we have a big problem. This is a big disaster.
After a harrowing half an hour, and with only inches to spare, the slab rests safely at the top and is moved into position. Over 10 months, engineers install thousands more floor slabs and put the finishing touches to the factory. Completion of the project is at last a success.
This is an exciting experience for me because we had to finish this big project in such a short time. And the precast helped us to accomplish this mission.
With the Innolux plant completed, engineers turn their attention to another mega project, the $70 million Taipei Stadium. It usually takes over 30 months to build a stadium this size. But engineers are going to use prefab to shave more than 5 months off the schedule. If they succeed, it will be the fastest stadium ever built in Taiwan. Only one problem. The city of Taipei sits on some of the softest soil on the island. A condition made worse by an extremely high water table that rises during the annual typhoon season. If engineers want to get the stadium ready in time, they will have to prevent it from sinking into the ground. Homegrown innovation has been the powerhouse that's propelled Taiwan into the future. The island's largest prefabrication factory is attempting its most ambitious projects to date, constructing 3 mega buildings in record times. Engineers took just 1 year to complete the massive 600,000 square meter Interlux plant. Now they turn their attention to their next 2 missions. The 38-story Ocean Blue condominium and the 22,000-seat Taipei Stadium. Commissioned specially for the 2009 Deaflympics, the stadium has to be ready in less than 25 months. It usually takes more than 30 months to complete something this big. If engineers succeed, they will make construction history. Engineer Zhang leads the project.
为了这个场馆的新建啊，为了要达到如期的完工，所以我们啊，在设计方面呢，在施工上我们采用了传统的工法，加上钢构的工法，以及搭配大部分的预铸工程。
Back at the prefab factory, engineers customize the stadium's 900 seating slabs. Specially designed molds of different sizes and shapes churn out the 15-centimeter thick parts. This way, 16 seating slabs can be completed in a single day. A feat conventional methods will find hard to beat.
预铸可以解决非常多的问题，它可以克服各种形状的板片，可以做弧形板或是直线板。
More than 40 steel trusses are also prefabricated to form the stadium's roof, each weighing 35 tons. Everything is ready to be assembled. But first, engineers have to overcome a sticky problem that could ruin their foundation. Soft clay. This unstable soil underlies Taipei because the city sits on a basin. And as the basin is intersected by 4 rivers, the soil also suffers from a high water table, just 2 meters beneath the surface.
要达到如期完工的过程啊，最重要的一点就是要克服台北市的一个地质的问题。
Complicating the problem even further is the threat posed by the engineer's deadliest foe: earthquakes.
Because the city of Taipei has a thick layer of soft soil. When earthquake comes, the earthquake wave would pass through this thick layer of soft soil, and some of the earthquake waves will be amplified. Therefore, the building built on this layer of soil could suffer serious vibrations.
For engineers to complete the stadium in time, they need a solution that will both stabilize their soft foundation and counter the threat of an earthquake.
好，那需要什么帮助的话？
Prefabrication can't help engineers in this situation. They need to come up with an alternative solution. One option is to drill steel foundation piles deep into the earth. But it's a time-consuming process, and the amount of steel needed makes it an expensive scheme. What's worse, An earthquake or a hidden pocket of clay could destabilize the steel piles, causing part of the stadium to collapse. Engineers turn to a conventional but highly effective technique to tackle both problems. Mat foundations. Engineers will excavate close to 5 meters down until they hit sand, a stronger and heavier material than clay. Then they'll place a bed of steel onto the sand, reinforced with concrete, creating a mat foundation. By building countless mat foundations around the 600-meter circumference of the stadium, the weight of the structure is distributed evenly across and under the site, allowing it to sit undisturbed within the soft clay and high water table. Even if an earthquake hits, the stadium will move as one in the soft soil, just like a ship floating at sea.
我们的结构部的结构计算呢，为了解决这个整个因为环状基础的开挖，经过了所有的检讨，认为说这个华式基础啊，是一个最优良的一个基础结构方式。
Work begins. First, engineers construct a series of waterproof steel structures called cofferdams. These temporary structures surround the worksite with a wall of steel sheet piles, making it safe to work inside. Then they assemble the steel skeleton of the mat foundation. Workers pour tons upon tons of fast-setting concrete to give the foundation its final shape. But before engineers can finish their work, disaster strikes. The annual typhoon season hits Taipei. A Category 2 typhoon makes landfall east of the city, causing flash floods and landslides, clocking wind speeds of more than 180 kilometers per hour. At the stadium, almost all the cofferdams are inundated with rain. It's a major setback for the crew.
我们就发现到这个淹水的深度啊，达到差不多有1公尺半左右啊，差不多一个人的深度了。哎，心理上就觉得非常的惶恐，也非常的无奈。但是呢，我们还是要准备很多的应变措施啊，比如说如何来防治台风的损害。
Engineers work non-stop to come up with the most efficient salvage plan. They use every pump at their disposal to discharge the water from the cofferdams.
那我们呢，马上就准备了大概有10台的5匹马力的的抽水机啊，运用外接的发电机来抽水，足足嘛抽了大概有3天的时间，为了不影响后续的工作。
Engineers overcome the potential disaster. Now they begin to assemble the rest of the structure at breakneck speed. The stadium's 900 seating slabs go into position in just 2 months. 3 men and a crane are all it takes to get the job done. And after bolting its massive roof trusses into place, Taipei Stadium begins to take its final shape. Engineers have successfully met their tight deadline.
能够把这个体育场啊，在工期之内，在品质的管控之内啊，如期的完成，感到非常的高兴。如果说今天这个场馆啊，用传统的工法来兴建它的话，起码比我们这个预铸的工法最少要多1年。
With the stadium complete, the prefab factory begins work on another giant project. a towering luxury condominium called Ocean Blue. At 38 stories, Ocean Blue will be the tallest prefab building in Taiwan, constructed in less than 2 years. Almost immediately, engineers face a major challenge. To make such a tall building earthquake-proof, they will have to build structural supports of near impossible dimensions.
If we use a conventional method, it definitely you will have a big column and a big beam. That will cost a lot of money, and because the big column and the beam will occupy a lot of space, it's not good for a residential building.
Engineers need to bring on state-of-the-art anti-earthquake technology and the magic of prefabrication to create this residential paradise by the sea. Behind the bustling, prosperous facade of one of Asia's economic powerhouses lurks a constant threat. Taiwan is at the mercy of one of nature's most powerful forces: earthquakes, some measuring more than 7 on the Richter scale. To protect its people and its cities, Taiwan turns to advanced building technology. Prefabricated construction could be the answer. A massive factory creates high-quality concrete building blocks with production line efficiency and then assembles them rapidly on site. Armed with a super tough steel skeleton, these blocks are strong enough to withstand an earthquake. Engineer Dr. Samuel Yin is proud of his achievements.
预铸呢，它分成里面的钢筋笼的技术、水泥成分的技术跟模板的技术。虽然这个技术呢，在几十年前苏联人就有，北欧就有。 但是我们把它做得更精进，更多的发明跟改善。
Taiwan's largest prefab factory is now facing its biggest challenge to date: building one of the city's tallest residential blocks, the 38-story Ocean Blue condominium. Engineers there are trying to overcome their first hurdle. As expected, the higher you go, the tougher it is to defend the building against earthquakes. To make Ocean Blue earthquake-proof, engineers will have to produce columns of impractical dimensions. They will be too expensive to produce and take up too much space in the structure. Engineers have to figure out a more practical solution.
Because earthquake is the most critical issue in Taiwan, so we must build this structure earthquake-proof.
Advanced bridge building technology may provide the key. Via seismic isolators, invented by New Zealand scientist Dr. William Robinson in the 1970s, seismic isolators are used in bridge construction to dissipate earthquake energy by up to 90%. Installing them under Ocean Blue could help minimize the size of its structural supports.
那各位可以想象，竹子在受到风吹的时候呢，它的动作是非常的软，但是它却很不容易折断。那 isolator 它的作用呢，就可以让我们的房子的结构行为，像受到地震来的时候，像竹子那样子的变软，所以呢，这样子可以保证我们结构的安全。
The secret behind this incredible invention lies within each isolator. Inside, layer upon layer of elastic rubber is sandwiched between powerful steel plates. They serve two purposes: to form a padded compact block to support the pressure of a building above it, and to maintain the shape of cylinders made out of lead, which is both dense but flexible. When an earthquake hits, the lead bends and adjusts easily with its lateral forces without fracturing, absorbing the energy and distributing it away from the supports of a building. It sounds like the perfect answer, but Ocean Blue engineers need to be sure. So they put the isolator through an earth-shattering test. Engineers plan to apply 140 tons of pressure to stress and strain the isolator laterally, adding another 1,200 tons of vertical force to simulate a section of the building's weight.
如果说没有在经过测验的情况下 ，isolator 在制造的过程中发生了品质的瑕疵，那有可能造成建筑物的破坏。即便在没有地震的情况下，那我们的建物就已经受到损坏，这样对我们的生命财产是没有保障的。
The test begins. Hour after hour, earthquake forces of 7 Richter and more strain the isolator mercilessly.
当我看到隔震器受测试的时候，它在承受这么大的一个变形位移，可是仍然有足够的能力去 take 这样的垂直荷重，让我感到非常的amazing。
At the end of the test, the verdict is unanimous. The isolators are ready to be installed. A total of 43 isolators will support Ocean Blue, the largest measuring close to 2 meters in diameter. These are the biggest isolators ever used in Taiwan. After 2 months of careful construction and installation, the isolators are finally in place.
This high-strength concrete column and this high-strength concrete base, and between these two structures is isolated. We are very happy we can complete it successfully.
With earthquake protection secured, engineers can now focus on prefabricating the rest of the structure. Conventional methods require 2 weeks to complete a floor. With prefab, each floor can be assembled in a record 8 days. But engineers cannot afford to be complacent. Ocean Blue is located on the coast of the Taiwan Straits. Gusts of wind here can hit speeds of more than 20 meters per second, making construction a nightmare. If engineers are not careful, the hoisting operation could easily turn into a disaster zone. Taiwan's destructive earthquakes have finally met their match. The island's largest prefabrication factory manufactures building blocks tough enough to protect structures from an earthquake.
这里面有牵涉到更多的跨科系的工艺，我们使用化学、物理跟这个电脑等科技整合的方法。
Now the factory is about to complete its latest project, Ocean Blue. Engineers are racing against time to assemble all 38 floors of the luxury condominium. Only one thing stands between them and success. The powerful winds of the Taiwan Straits. Ocean blue is right on the coast. Wind speeds here can reach more than 20 meters per second. The higher engineers build, the stronger the wind, making assembly work a tricky business. For Engineer Lin, it's a weighty responsibility.
The most dangerous part of this process, we should consider about the wind force. If the wind force too heavy, too strong, maybe cause the slab to hit the building.
One last floor remains to be assembled. Level 38. Time for some serious lifting grunt. A 440-ton crane will hoist more than 60 balcony slabs and columns. Some weighing almost 20 tons. It's fraught with danger. And engineers have only 5 hours to get it done. A single mistake or a strong gust of wind can throw the entire operation into chaos.
A little bit nervous. We should be quite carefully. Because underneath should be no people underneath the slab. If anything happen, may cause big trouble. Okay, you can see the slab almost go to the top. Okay, let's go.
On the top floor, a small army of workers assemble the balcony slabs, beams and columns with rapid precision. They know that the longer it takes, the bigger the chance of something going wrong.
This is like Lego, but it's million times harder and bigger.
As the 5-hour mark draws to a close, the last pieces of the floor finally make the climb and are welded into place. With Ocean Blue now completed, Taiwan's largest prefab factory has achieved its goal of customizing its unique method for buildings of all shapes and sizes. Besides creating the towering 38-story luxury condominium, they've also constructed a $1 billion high-tech factory and the 22,000-seat Taipei Stadium. For the factory's creator, Dr. Samuel Yin, success has caught the attention of some of the world's top engineers. In 2008, the Russian National Academy of Engineering awards him with their first Medal of Honor and elects him as an academician. Only 7 awards have been given out to date. Samuel receives the 8th from then Russian Prime Minister Viktor Zubkov.
这个呢是给我一个更大的一个新的一个社会责任，我会不停的继续的在发明，继续在改善。其实还有一个案，我把这个。
Dr. Yin's next goal: to take his anti-earthquake designs to China. A massive 8 Richter quake has laid waste to the province of Sichuan. Thousands of people lost their lives, and millions are left homeless.
因为你会问我说哈，我们润泰盖的房子哪一栋是最好的？我肯定的告诉你是下一栋。
接下来，主持人史蒂夫·楚伊特为你拆解最神奇的现代发明，揭露精彩创意背后如何运作的秘密。原来如此，接着播出。